This next topic is a big one in, any kind of higher level mathematics, even in your algebra 2, pre-cal, calculus. This topic is so necessary for, when we simplify expressions, when we solve certain types of equations, we need to know how to what's called factor. All right, so we start off with just a quick little synopsis here, and I know you're familiar with these, and it's not that I'm going to show you any new types of factoring that we're going to do, but just kind of refresh your memory on the old types so that we're well versed and we can handle any type of factoring that we see. All right, what factoring is? It's writing a polynomial as a product of polynomials. All right, so what you have here are examples of polynomials. Now, for some polynomials, depending on how many terms they have, we give them special names. Now, this guy right here, it's known as a monomial. Now, monomials we generally don't factor. A monomial is just, there's no addition, there's no subtraction, it's just all multiplication. Right? 15x squared is called a monomial. And a monomial, in terms of polynomials, it's known as also a term. So when we say this particular polynomial has three terms to it, we mean this particular polynomial is made up of three monomials being added together. Right? So these monomials, we tend to not factor because there's really no point. Now, can we factor them? Can we write them as a product of other monomials in this case? And the answer is yeah. You could say 15x is 3 times 5x squared. But you could also say it's 15 times x squared. You could say it's 3x times 5x. There's many ways to represent 15x squared, and none of them are particularly super useful to us, and they're not really in the spirit of what we say when we say factor a polynomial, but we have to throw this in as, it's a polynomial, and there's occasions where we're going to want to write it as a product, but generally that's not what we're thinking of when we think of factoring. Right? We're more or less thinking of the polynomials that have 2 terms to them, or 3 terms, or even 4 terms. All right, so this right here has 2 terms to it. It's a polynomial, but it has a specific name. It's called a binomial. It's made up of 2 monomials. What are the monomials? Well, 4x squared and 81. They're not being multiplied. They're being, in this case, subtracted. So that's 2 distinct monomials. That makes what we call a binomial. All right, down here we have what's known as a trinomial, made up of 3 terms. And we can say the same is true about that last one, also made up of 3 terms. Now, there are such things as 4-term polynomials. They're not called quadnomials. We just say 4 terms or 5 terms or 6 terms. There's no special name after 3. So there's monomials, which is known as actually a term when we talk about polynomials. There's 2-term polynomials. We call them binomials. 3 terms, we call them trinomials. After that, just 4, 5, 6 terms, whichever. Right? But as you know, we concentrate, we tend to focus in on the binomials and the trinomials when we go to factor these things. And what we're saying is, how could you rewrite 4x squared minus 81 as the product, meaning multiplication, of 2 other polynomials? Well, as it turns out, 4x squared minus 81 can be written as 2 other binomials that are being multiplied together. They would be 4x plus 9, 4x minus 9. In other words, 4x squared minus 81 is the exact same thing as this. You're looking at those and say, who cares? Why can't we just write 4x squared minus 81? Because a lot of times, in its factored form, another representation of this might help us to simplify a complicated expression, or it may help us to solve a difficult equation, right? And both statements are true because that's what it's going to do for us. Factoring is a very useful tool for getting to solutions of certain types of equations and simplifying complicated expressions. Right? This guy right here also can be represented as the product of 2 binomials. That would be x minus 5 times x plus 4. Now you might recognize we can multiply these two using what's called FOIL, first, outer, and last. If you do FOIL to this, you do get this statement back. So these are the same thing. It's as if I said, okay, you can write 40 or you can write 8 times 5. Are these the same statement? Yeah, they are. But this one's simplified, this one is not. I'm writing 40 as a product of its factors. They're the same thing, but they're just different representations. They look different, right? And that's kind of the idea here. Yeah, they look very different. X minus 5 times x plus 4 looks very different than x squared minus x minus 20, but they are the same thing. Okay, this one looks even rougher, but it does factor to x minus 6 quantity squared. Right? Same idea. We can write this as a product of its factors. What are its factors? Well, x times 2 factors of x minus 6. Right? So you're just writing a polynomial as a product of other polynomials, or we could say more specifically as a product of its factors. Right? That's what factoring is. Well, as far as the certain types of factoring go, the first one is by far, I think, the most important. You always first look for what we call the GCF. And hopefully you know by now, GCF stands for greatest common factor. So if I had something like, say, 13x to the 5th minus 39x cubed. I said, well, let's factor this. Well, the first thing we're looking for is that greatest common factor. Right? You have two monomials. This is called a binomial. Look at the two terms of this binomial and ask yourself, what's the largest factor that's common to both? Right? Well, I always start with the numbers, 13 and 39. What's the largest number that divides into both 13 and 39? The answer would be 13 itself. Right? Now, keep going. What about the x's? This has 5 factors of x. This has 3 factors of x. What's the most amount of factors that are in common to 5 and 3? The answer would be 3 factors. So 13x cubed would be my greatest common factor. Now, that doesn't mean you're done. That's not factored. 13x to the 5th minus 39x to the 3rd does not equal 13x cubed. It's got to equal. Both sides have got to be the same. So 13x cubed is one of the factors, and now you're going to find the other factor by undistributing. Right? You know, with distributing, you multiply. Undistributing, you're actually dividing. So we ask ourselves, what do I have to multiply 13x cubed by to get 13x to the 5th? Or what's 13x to the 5th divided by the GCF? Well, if you divide 13x to the 5th divided by the GCF, you're going to get x squared. Take negative 39x cubed divided by the GCF. You're going to get negative 3. And we can check our GCF factoring by, first of all, making sure the GCF of what's inside the parentheses is 1. Right? X squared and 3 have no common factors, so that's safe. And then distribute. If you took 13x cubed times x squared, you do get 13x to the 5th. 13x cubed times negative 3 is negative 39x cubed. We have successfully factored. We have written this polynomial as a product of its factors, or as other polynomials, a monomial and a binomial. Right? Now, just one thing you have to kind of be cautious on when you do GCF, and that is a classic mistake. If we have, say, let's go x cubed minus 7x squared plus x. All right, let's take a trinomial like this. You're looking for a greatest common factor. Well, might as well start with the numbers. 1, negative 7, or let's just say 1, 7, and 1. The greatest common factor is 1. So we'll put a 1 just for a placeholder. 3 factors of x, 2 factors of x, 1 factor of x. What's the largest amount of factors of x they have in common? That would be just 1 factor of x. So 1x, or just x itself, is a better answer. That's your GCF. Now you have to undistribute that from this trinomial. In other words, what's x cubed divided by the GCF? Negative 7x squared divided by the GCF. And here's where people get in trouble. X divided by the GCF. A lot of people say that's 0. No, it's not 0. A number divided by itself is not 0. A number divided by itself is always 1. Unless you're talking 0 divided by 0, which we're not talking about. So, x divided by the GCF, that has to be there. If it's not there, when you distribute, this term vanishes. It's like it was never there. If I just write this and distribute, yeah, I get that term back, I get that term back. But the question is, what happened to that term? Where did it go? Well, that's why you need a 1 there, not a 0, because 0 times x would be a 0, and that term's gone. It needs to be a 1 there, so that 1 is a very important number to write in there. You don't think it's significant, but you're getting it confused with multiplying by 1 doesn't change anything. Adding 1 definitely changes things. So, in the next video, hopefully we can wrap up the rest of the factoring, just kind of refresh your memory about all those other types. And we're going to kind of leave off a couple that you learned in Algebra 2. Grouping, not going to focus in so much on that, and sum or difference of cubes. So those two we'll throw off the list. Should make this go pretty quickly, and we should be able to get it all in the next video.